All right, so I'll record this. Let's start. People can come as they log in. There's no waiting room. This is the last chapter we're going to deal with before the exam next week, and chapters 4, 5, and 6 each put a layer on our model of consumer choice. Chapter 4 introduced indifference curves and the notion of tastes and preferences, and then chapter 5 introduced market prices and constraints on the consumer and illustrated how a consumer goes about making trades so that that consumer can maximize their utility in consumption. And now chapter 6 has looked at how changes in prices affect a consumer's welfare and the ways we go about measuring these changes in a consumer's welfare. So each of these chapters, of course, built on the one before it. And here at the end, this chapter, the most difficult material in this chapter is the decomposition of the change in quantity demanded as a consequence of a price increase as a result of two effects, the income effect and the substitution effect. And this deconstruction of that change is what I think in my experience over the years of teaching this class is perhaps one of the most difficult chapters in the course over the course of this semester. So before I go any further, let me ask you, does anybody have any questions? Anything they want to say? Ask me. Anyone? Okay. Yeah.
Dr. McComb, can you hear me okay?
Yeah.
I was just going to ask you if you might post this lecture recording on YouTube or Blackboard. My data connection's kind of weird today.
Yeah, I am recording this one. I didn't record my earlier class, but I got this one recording, so I'll be able to post it.
Okay, perfect. Thank you.
Any other questions? Any other material related questions? All right. Well, I'm going to go to my my whiteboard here and just kind of try and review income and substitution effects to see if I can get it to the point where it makes sense to you guys how I go about doing this. So here we go. What I was trying to say in my recorded lecture is that it is useful for us in economics, and to a large extent, Economics 3312 is a course trying to provide you with tools to go on in other areas of economics. Microeconomics itself, intermediate microeconomics, somebody's got their mic unmuted that's making noise. So what we're trying to do in this course is to build tools that you'll use in other contexts in economics. So, we go through income and substitution effects, and it seems kind of like a pointless exercise, I think, to most students, because you don't really use, these separate effects in any way in this class. We're just putting the model together. So, I tried to give an example of where we can use the idea of compensating variation as a way of determining whether an individual can be made better or worse off through some sort of, government policy or government action. It's a tool like if you were to take, say, another course that's in an area of welfare economics, such as what we call public finance or even industrial organization. Some of those classes, this distinction would be useful between substitution effects and income effects. But let me just try and draw this out for you guys and see if it makes sense what I'm doing. And what I want to do is focus here on the good X. And I want to think about what I'm doing. I've got an individual who has some initial level of income M, and there's some initial price of Y, and there's also some initial price for X. And so that establishes this constraint of affordability for our consumer. And we argued in the last chapter then that this consumer, faced with this budget constraint, would choose a bundle that maximized utility by picking a point on the budget constraint line that was just tangent to an indifference curve. And I'm calling this point A here. And at point A, what I know is the marginal rate of substitution is equal to the price ratio, which is the negative of this slope of this budget constraint line. And so there's my individual who's maximizing utility. Now, we know this. We know that if the price of X were to go up, the individual would lose purchasing power, and the budget constraint line would pivot in to reflect this reduction in purchasing power. And so if we have this new price of X that's greater than the original price of X, then my consumer can buy less X, of course, but notice for anybody, consumer who buys some X, the consumer also loses the ability to buy Y as well. So there's a couple of things we're saying is going on here. We're saying on the one hand, the consumer finds that the price of X has risen relative to the price of Y, and so the consumer substitutes away from the price from X. But we also have displayed here with this shift in the budget constraint line how a consumer's purchasing power falls. So the consumer not only substitutes away from X owing to the fact that X is now relatively more expensive, but the consumer's purchasing power also causes the consumer to buy less X and less Y if they're both normal goods. And so the consumer would move to a point here. Let me call this point C. That represents then the new utility maximizing consumption bundle after the price of X is increased, all else equal. And so we have, a consumer who was initially consuming this quantity of X, who after the price of X increases is now consuming this quantity of X. And we say that this difference here between the original X and the new X is the uncompensated change in quantity of X demanded. Right? So that's the uncompensated change. But we know that it consists of the two effects that we want to separate out. The substitution effect due to the relatively higher price of X, and the income effect due to the loss of purchasing power. So what I want to show you here today is, again, just kind of try and demystify this, because people look at it as difficult. I don't want you to think of it as being difficult. What I want you to think of it as being is maybe complicated, but not difficult. Now, here's what I want to do. Here's my strategy here. I know this, that the uncompensated change in quantity demanded, this is, from my drawing from A to C, that movement, the uncompensated change is then the sum of these two separate effects, which is the compensated change or we also call this the substitution effect plus the income effect, or the purchasing power issue. Now, what I'm going to do in all of these cases is I have this equality. So if I know the uncompensated change and I know the compensated change, then I can find the income effect. Whenever I know two of these three quantities, you know, if I knew the compensated change and the income effect, I would have the uncompensated change. If I had the income effect and the uncompensated change, I could find the compensated change. So whenever I have two of these three, I can always find the third. Now, I've already found the uncompensated change. I said we went from A to C. So that was my uncompensated change. How do I find then one of the two other ones? And the one that I think is easiest to find that makes this whole problem more tractable is to first locate the substitution effect. And how I define the substitution effect is the change in quantity demanded of X at the new price holding utility constant. So I'm going to, at the initial level of utility. So I'm going to look, you know, initially at the original income and the original set of prices, my consumer was able to achieve utility level, let's say U bar. So what I'm going to say here now to find the substitution effect is pretty straightforward. I'm going to say, okay, let's move to the new prices and find a point on the original indifference curve where the marginal rate of substitution is equal to the new prices. So in other words, I'm going to look for a point. I'm going to need the slope of my new budget constraint line here, which is about like that. It's parallel to this one. And right at this point here, where the slope of this is now my new price ratio, the negative of my new price ratio, and this is the same here. Right at this point, the original indifference curve is just tangent to the new budget line. So right at this point, that must mean, and we call this point B. At point B, that must mean the marginal rate of substitution is equal to the new price ratio. And so my substitution effect then is the movement from A to B, or expressing this in terms of changes in X, quantity demanded of X, it would be this movement from X sub A to X sub B. So this would be my substitution effect here. And then the residual must necessarily be the income effect, because the substitution effect plus the income effect make up the uncompensated change in quantity demanded. All right, so what do I have here? I've got at point B, I have the substitution effect, and then I have this movement from B to C, which is the income effect. So from A to B is my substitution effect, and from B to C is my income effect. But you can see when I add these two together, I get from A to C by virtue of these two separate effects. Now note, when I found the substitution effect at the point B in my drawing, the marginal rate of substitution, we said, was equal to the new price ratio. But on the original indifference curve. So my method for finding the substitution effect is fairly straightforward. I know the MRS, I have an expression for the MRS. So I set that, let me just write this out. So to find, the value, the point B, I set marginal rate of substitution equal to the new price ratio. Solve for X or Y in terms of the other. For example, X. No, I'm going to make that Y because it's what I usually do. Y in terms of X. Now, what I'm going to do here and why I'm doing this is I have a utility function, which is some expression in both X and Y. And what I'm saying here is that utility at the initial set of prices and income was U bar. So that's why I'm going to hold constant. I'm going to set utility constant to U bar. And what I'm going to do is then after the price change, I substitute X, for Y in the utility function. And I have a specific value that the utility function has to be equal to, so I have a single equation in one unknown. So the utility function becomes an equation in one unknown. In this case, it would be X. So I solve for X. Then I can use, Y in terms of X. I can get Y. And these will be values. These will be values that yield a level of utility of U bar at P prime and Py. All right, so let me just do the example that I did in class, and there's some problems in the chapter problems that I think are pretty good. But here's where I'm at here. My example. Here's my utility function. I say that the individual's utility function is the square root of X times the square root of Y. And we know with this utility function that the marginal utility of X is, 1/2, X over Y to the 1/2, Y over X to the 1/2. And the marginal utility of Y is 1/2 X over Y to the 1/2. And so together, the MRS then, we said, simplifies out to Y over X. So I know what the individual's marginal rate of substitution is. It's always Y over X. And this has nothing to do with market prices. This simply has to do with my individual's tastes and preferences that yields this willingness to trade that depends on the specific values of the two goods that the individual has. Now, we start off in here, we say when we bring in the market, then in this example, wherever I have this example, see here, we said that the individual has he has an income of 200 and has to pay 2 for each X and has to pay 4 for each Y. So my initial circumstances then are such that the individual will, subject to this constraint, this budget constraint, will choose X and Y to maximize utility, subject to the budget constraint, by choosing the bundle on the budget constraint line where margin rate of substitution, which we said is y over x, is equal to the price ratio of x to y, which is just 1/2, equals initial price of x over price of y. So we have this condition right here. So we know that y over x will have to be equal to 1/2, which tells us then that y must necessarily be equal to x over 2. So we don't know what the solution is yet, but we do know when we find the solution, y will be 1/2 of x. So I have y expressed in terms of x. Now I go back to my budget constraint and I say, well, we pay 2 for each x and we pay 4 for each y, but y has to be equal to x over 2. So I've got my budget constraint reduced to an equation in one unknown, 4x, and this must be equal to the consumer's income. So that means x will be 50 and y will be 25 because it's half of 50. So I have the initial conditions for my consumer. My consumer chooses a bundle consisting of 50 units of x and 25 units of y. So here I am. I've got x, I've got y, I've got, could buy a maximum of 100 x's, could buy a maximum of 50 y's. And the budget constraint line has a slope of minus 2 over 4 or minus 1/2. And my consumer purchases a bundle then that consists of, it works out to be the midpoint on this thing. This is my bundle A. Before purchases 50x and 25y. And right at this point, then the slope of the indifference curve, the MRS, is equal to the negative of the slope of the indifference curve, which is 1/2. So the MRS is equal to 1/2 at this point. Let me just go ahead and call it point A. And I have then my values of x at point A. Now, when we talk about a change in the price of x, then let me suppose that the price of x p prime of x is equal to 4. So the price of x has risen. Now, what that says is that in reality, my consumer now faces a budget constraint line that has a slope of -1. Minus 4 over 4. So in this particular example here, my relative price of x is now 1. So that's the slope of the budget constraint line. So what is my consumer going to do? My consumer is going to remaximize. We'll say to point, make this point C here. How's my consumer going to do that? Well, my consumer is going to say, all right, I know my marginal rate of substitution, y over x, must be equal to 1, relative price ratio, which tells me that y will be equal to x. So again, I don't know my solution yet, but I do know at that solution, y will be equal to x. So what do? Well, I go back to my budget constraint. Now the price of x is 4, so I have 4x plus 4y, but y must be equal to x, so I have 8x is equal to 200, so x must be equal to 25. So right at this point now, at C, I've got an x equal to 25, and I've got a y equal to 25. Okay, so both x and y are equal to 25. Now, this is the uncompensated change. This is what we observe. incompensated change in quantity demanded of X now is going to be equal to, well, it's 25 afterwards. It was 50 initially, so it's going to be equal to minus 25. That's the uncompensated change. That includes both the compensated change, the substitution effect, and the income effect at minus 25. So we want to decompose this into its component parts. And like I say, let's find the substitution effect. And if we find the substitution effect, then we'll know what the income effect is, because the substitution and income effect have to add up to minus 25. So we find the substitution effect first. Well, I have to find out what the initial level of utility was. So initial utility is equal to, well, the square root of X times the square root of Y, which works out to be 35.35. All right, so coming back to my drawing here, the utility of all the bundles on this line here generate a utility of 35.35. So that's my initial utility that I'm going to use to find the substitution effect. And how I'm going to find the substitution effect is I'm going to look for the spot on that original indifference curve, utility 35.35, where the slope is minus 1. And I find it right here. This is my point B. And at this point, I know that since that budget constraint line is just tangent to the indifference curve, that this is where the margin rate of substitution is equal to 1. It's the same slope. These two budget lines here that generate points C and B have the same slope. I've gone to the new price ratio and found a budget line at the new price ratio that's just tangent to my original or initial indifference curve. So I know this. I know that the margin rate of substitution at point B is going to be equal to 1, because that is the new price ratio. Which is 4/4 in our example. All right, so if this has to hold, then at point B, Y must be equal to X, since their ratio is equal to 1. Now, that means my utility function, which is the square root of X times the square root of Y, if Y is equal to X, just becomes X to the 1/2 times X to the 1/2, which is just X, and that has to be equal to 35.35. So I found my substitution effect. I found that at point B, X must be 35.35 at point B. And of course, Y has to be 35.35 too, because it's equal to X at point B. Now, what's the utility? Well, utility is square root of 35.35 times square root of 35.35, which is 35.35. So I have solved my problem here in that I have identified the substitution effect. And so the substitution effect is the change in quantity demanded moving along that indifference curve associated with 35.35. And we went from 50 units of X to 35.35, so the substitution effect is a decrease of 14.65. Now, that is due entirely to the change in the price of X, the increase in the price of X, inducing this individual to substitute away from the now higher price to X. And the direction of that change is always going to be substitute away from if it has a higher price, substitute toward if it has a lower price. So the substitution effect is pretty straightforward here once I figure out how to find that point on the original indifference curve. right, that reflects the new MRS as a consequence of the change in the relative price. So now coming back, where's my income effect? Well, the income effect has to be, I've got the uncompensated change, which we said was minus 50. We're saying that this is equal to the compensated change, or the substitution effect, which is minus 14.65, plus the income effect has to, minus 14.65 plus the income effect has to add up to 50. So the income effect must be an additional 9.35. And so these two together add up to the, just a second here. Uncompensated change, we said it wasn't, was it 50? No, it wasn't. It was, yeah, it went from 100 to 50. So this must be whatever this works out to be. Was it originally 50? I can't remember. I've already forgotten. No, the uncompensated change is 25. So uncompensated change 25. Get rid of this. All right, so that is right, 9.35. Together they have to sum to the uncompensated change. That's always how I'm going to do it. It's easiest that way. So I'm always going to, so I find the initial bundle, which, I just call XA, YA to associate with my point A in the drawing. And then after price change, I find the new uncompensated bundle, so first find the initial bundle, after price change find the uncompensated bundle, and then 3, to find substitution effect, find initial utility, value, then solve for y in terms of x, substitute for y in the utility function, substitute for y in the utility function, and solve for x at initial utility level. Reflecting new MRS. And I'm basically done. Subtract the compensated change, quantity demanded, from the uncompensated change, find income effect. That's how I would do it every time. And that's, how it is, I think, for you, easiest. Let me do an example that's in the back of the textbook. Let me do problem 10, number 10, in chapter 6 on page 199. And this has a little different sort of utility function, so to give you a different look at it. So what we have in this problem is Antonio's utility function for the goods X and Y So Antonio's utility function is equal to 2 times the quantity square root of x plus square root of y. Now, this yields marginal utilities of 2 times, well, it's going to be 1/2 x to the minus 1/2. And this simplifies actually to 1 over square root of x. And the marginal utility of y is going to be 2 times 1/2 y to the minus 1/2, which simplifies to 1 over square root of y. So that yields for us a marginal rate of substitution, our expression in terms of x and y, of 1 over square root of x over 1 over square root of y, which simplifies to square root of y over square root of x. So there is the marginal rate of substitution, square root of y over the square root of x. So the problem says, do Antonio's preferences satisfy the declining MRS property? Well, looking at this, I can see, whenever I ask myself if something satisfies the declining MRS property, I think of movement along the indifference curve. And, remembering that more is better means my indifference curve has to have a downward slope. I think of moving, from, down an indifference curve, so reducing the amount of y and increasing the amount of x. And if I look at this ratio, if I decrease y and increase x, that means that the numerator in this expression is decreasing, the denominator is increasing. That tells me that delta y over delta x is decreasing. So the answer to A is yes, it does satisfy the declining MRS property. Then it says, suppose, part B, suppose his monthly income is $1,800 and X and Y both cost $1 per unit. What is his best choice? So this is my basic constrained maximization problem, and I'm going to find the best choice by first setting the marginal rate of substitution equal to the price ratio, which is just going to be 1. So that tells me then at my solution, the square root of y will be equal to square root of x, or y will be equal to x at the solution. And then, I take this, I've got y in terms of x. I know each unit of x costs 1, so there's my expenditure on x. And there's my expenditure on y, since this price is also 1. But since y is equal to x, this is just going to be 2x, and that's going to be equal to 1,800. So my initial quantity of x demanded is going to be 1,800 over 2. So x is equal to 900, and y is equal to x, so it's equal to 900. So that is Antonio's initial consumption bundle when his income is 1,800 and the price of both x and y are equal to 1. Now note here, what's utility level? Utility is equal to 2 times the square root of 900 plus the square root of 900. So this is going to be 2 times 30 plus 30, or 60, equals 120. So the level of utility that Antonio achieves with an income of 1,800, price of X1, price of Y1, is 120. That's his utility index. Now, part C here. Suppose the price of good X rises to 2. So P prime of X is now equal to 2. So let me first find the uncompensated change in quantity demanded of X. Okay, I'm now going to go back. I've got square root of Y over square root of X is now going to be equal to 2 over 1, or 2, which tells me then that at my solution, the square root of Y will be equal to 2 times the square root of X. We square both sides. That tells me that y then will be equal to 4x at the solution. Now, each unit of x costs 2, so I have 2x. It's my expenditure on x. Y still has a price of 1, but I substitute for y in terms of x. So I get 6x is equal to the income of 1,800. So that tells me that x is equal to 1,800 over 6, or 300. Now, what's the uncompensated change? It's going to be 300 minus the initial value, 900, so it's minus 600. So when the price of x doubles, the quantity demanded by Antonio here falls by 600 units, from 900 to 300. Now, let's break this down into the compensated and income effect, or the substitution income effect. The compensated change is found by, okay, first, we're going to set the marginal rate of substitution equal to the price ratio, which we said means that at the solution, y will be equal to 4x. So I know that's the solution, but I also know that the initial level of utility that we found was 120. So what that means is that since the utility function is 2 times the square root of x plus the square root of y, I'm going to substitute. I've got 2 times square root of x plus I eliminate y by simply setting in here 4x. And note that this is then equal to 2 times, or 6 times the square root of x. This is in here is, it's 2 square roots of x plus the square root of x is 3 square roots of x. So it's equal to 6 square roots of x, which means then if our initial level is 120, we would set utility equal to 120. So the square root of x then is going to be equal to 120 over 6, or 20. So x must be equal to 20 squared, or 400. So I found the compensated change in quantity demanded. So the compensated change is going to be equal to 400 minus the initial 900. It's going to be equal to minus 500. We said the uncompensated change was equal to minus 600. It went from 900 to 300. So the residual here, the only thing that's what's left over, what we haven't accounted for, is the income effect. And since the substitution for compensated change and the income effect have to add up to the uncompensated change, that must mean the income effect is minus 100. So that this plus this equals that. That's 600. That's how I'm going to do this every time. But the key, for me here is to recognize, first off, I have to understand the difference between a compensated and an uncompensated change in quantity demanded. And once I have that distinction, and I recognize that the uncompensated change must be equal to the compensated change plus the income effect, then I can solve. When I have the uncompensated and the compensated change, I can solve for the income effect, and I have the solution in hand. All right, anybody want to say anything? Any questions? Anything clarified? Can you do that? I'm going to ask you to do it on Wednesday of next week. Now I try to give you a 1, 2, 3 kind of a method there, but you're going to need to recognize that the compensated change is going to be that movement along the initial indifference curve. There's no question about it. students struggle more with these income substitution effects than any other part. But if you're going to go on in economics and to take some other classes, then this distinction will be real useful for you. All right. No questions, comments, complaints, fulminations? Anybody still there? I don't see anybody moving. I just see people's pictures and choices. So, all right. Then I will let you go. I'll see you on Monday. Bye-bye.